Find first problem. L inverse 1 over root s plus 1. Second problem. L inverse s plus 3 divided by s square minus 6s plus 13. Solution. L inverse 1 over root s plus 1. There is only one s term which is in the form of s plus a, where a is equal to 1. Just compare L inverse of f bar of s plus a. So answer is e power minus 80, a is equal to minus 1, a is equal to 1, into L inverse, what I gave here, e power minus 80, L inverse, s plus a is replaced by s. Here s plus 1 is replaced by s. So 1 over root s. So this compare 1 over root s comparing with 1 over s power n plus 1. Okay. L inverse minus of plus 1. It is in the form of 1 by s power n plus 1, where n is a fraction. In the inverse formula, last one. What is that? T power n, t power minus 1 by 2, gamma n plus 1. That becomes again gamma 1 by 2. So this is e power minus t root over pi t. T power minus half comes down, becomes square root t, and gamma half is root by merge with and expressed in the form of root over pi t. Now see, second problem. Numerator is s plus a form. Denominator not directly s plus a or s minus a. So first you find a factors obtaining or not. If you get a obtain factors, then partial fraction method allowed. Otherwise, using first shifting theorem, provided the denominator is in the form of a perfect square method, that is a plus b whole square, a minus b whole square, express some of the terms into like that. Okay. So here I am doing s square minus 6s plus 13, which we have done in intermediate, 11th, 12th standard integrations. A square, first term in the form of s square. Minus 6s can be written as minus 2 into s into 3. So it is in the form of minus 2ab, where b is equal to 3. So borrow b square from 13, that is plus 3 square plus 4. I can write 13 can be written as like that. The first three terms is in the form of a minus b whole square. So s minus 3 whole square plus 4. So substitute here. This is equal to L inverse s plus 3 divided by s minus 3 whole square plus 4. So here it is a mixed case. Numerator s plus a and denominator is s minus 3. So you bring into any one of these. Either all are in s plus a or all are in s minus a. So but making the denominator term into s plus a is difficult. Okay. So it is already whole square term. So better to make this s plus 3 into s minus 3 form just by doing subtracting 3 and adding 3. But it is here difficult to make into s plus 3 form. Okay. So it is also we can write s plus 3 minus 3 adding and subtracting 3. But the problem going to complicate. In the next step we do not compare that term with any of the previous formulas. Okay. So L inverse s minus 3 plus 6. I can write like this. Okay. Now other than constant everywhere in the form, wherever it is s, it is in the form of s minus a. So entire function you now compare with L inverse of f bar of s minus a. So where a is equal to 3. So this is e power 3t into L inverse what I gave, s minus is replaced by s. So here all s minus 3 is replaced by s. S plus 6 remaining things comes as it easily. S square plus 4, since A is equal to 3 by FST, first shifting theorem. And you know how to evaluate, just by splitting into fractions, which I have done earlier. Basic model inverse problems, first model inverse problems, second problem example. Okay, so this is equal to e power 3t into L inverse, separating into fractions, s by s square plus 4 plus 6 times 1 over s square plus 4, and you complete. S over s square plus 4 is cos 2t, 1 over s square plus 4 is sin 2t by 2. Later you simplify. Next one is second property. Multiplication by t power n is equal to 1, 2, so on, natural numbers. Common sentences in all the properties I already explained. If L of f of t is equal to f bar s, that is, in the problems you properly select f of t. L of t times f of t is equal to minus 1 whole power 1 d by ds of f bar s. L of t square f of t is equal to minus 1 whole square d square by ds square f bar s, so on. L of t power n f of t is equal to minus 1 whole power n d power n ds power n f bar s. Here I have written small s, no problem. Just if one time in the product of t terms, if one of the term is t power 1 or t square or t cube, etc., then the remaining product terms taken to be f of t, find its Laplace. L of f of t is equal to f bar s, that is your basic step. Then go by this property. If one time multiplying by t, then right side minus 1 raised to 1, one time derivative to f bar s with respect to s. If 2 times of t, that is t square multiplying, then 2 times of derivative with respect to the f bar s, pre-multiplying by minus 1 whole square. Just writing in reverse order, L is going to that side, L inverse, and then bring the remaining terms to this side. That is called inverse Laplace transform property. what I am giving here directly, standard result, d power n ds power n f bar of s is equal to minus 1 whole power n t power n f of t. N is equal to 1, 2, 3. Example, see. So this is given (2008) 2 marks. L of t sin t. So here this term is taken to be f of t, comparing with this property. Okay. Solution. Since L of sin a t a is equal to 1, a over s square plus a square. Therefore, by multiplication with t, comma, L of t into f of t, that is f of t is sin t, minus 1 whole power 1 d by ds, that is f bar s, 1 over s square plus 1. This is your f bar of s, and this term is, I took standard term f of t, comparing with this property. So what is 1 over s square plus 1 derivative? Minus 1 into minus 1 divided by s square plus 1 whole square into 2s, using standard differentiation procedure, or you can apply u by v rule, quotient rule. So whole square, this is the answer. So if e power at, e power minus at multiplying, then give the preference the property first shifting theorem. Otherwise, the remaining one of the properties. If it is t square multiplying, then apply the problem, that is apply the property multiplication by t to the given problem. Okay. Next, third one. Division by t or t power n. N is equal to 1, 2, etc. Again, the common sentence for all these properties, if L of f of t is equal to f bar s, that means in the given product of the t terms, you properly select f of t and find its Laplace transform, which gives some answer that is denoted by f bar s. Okay, then apply the respective property. L of, sorry, now it is dividing. F of t by t is equal to integral over s to infinity f bar s ds. Earlier multiplied by t, multiplication by t. So the right side I have done, I have given that d by ds, derivative with respect. Now multiplication of opposite is division. So derivative operator, that is derivative opposite is integration. Okay. L of f of t by t square, 2 times dividing by t. Earlier 2 times multiplying by t, there I gave that 2 times of derivative, here 2 times of integrations. Integral s to infinity f bar s ds ds, and so on. Just write this L into that inverse problem in reverse order. L inverse of this is equal to like no change. Sometimes property statements also asking the using options or without options also, fill in the blanks also. Not only the problem, sometimes directly questions containing the statements, either Laplace statements or inverse statements. So one of the result in inverse I am writing in reverse order. L inverse integral s to infinity f bar s ds is equal to f of t divided by t, so on. So in this inverse chapter, this is a property called as inverse Laplace transform of integrals. Example, find L of sin AT by t. So comparing with the property, what is the proper value of f of t? Selecting f of t divided by t, excluding that t, remaining term is nothing but here sin AT is f of t. Since L of sin AT is equal to a over s square plus a square, so this is f bar of s, this is f of t. Therefore, by division with t, L of sin AT by t, f of t by t is equal to integral s to infinity f bar s. What is f bar s? We got a over s square plus a square ds. So integral 1 over x square plus a square is 1 over a tan inverse x over a, that formula, integration standard formula. So this integration is tan inverse s by a, limits s to infinity. Substituting infinity, tan inverse infinity, first one, lower limit, before that minus, s is replaced by s, that means giving same answer, same term. Tan 90 infinity, so tan inverse infinity is 90. 90 minus tan inverse is cot inverse. Since tan inverse x plus cot inverse x is equal to pi by 2. One by x square plus a square integration is 1 by a into tan inverse x by a. Remember the standard integration formula. Laplace transform of derivatives. LT stands for Laplace transform. Common sentence again, if L of f of t is equal to f bar s, then L of f dash t, here f of t is continuous and f dash t is piecewise continuous, okay, is equal to s f bar s minus f of 0 L of f double dash t. This property is useful in the last session of Laplace transform, last topic, that is solving ODE, ordinary differential equation. Without this property we cannot solve that problems. Okay, that's why this property is important. Using statement purpose, that means the question is coming directly by using what is L of f dash t. Sometimes the question is coming, what is L of f double dash t. Sometimes, okay, the differential equations which are not solved by which cannot be solved by that auxiliary equation CF, some problems are there, that problems can be solved by Laplace transform, first of all with the help of this property. S square f bar s minus s f of 0 minus f dash 0 L of f triple dash t is equal to s cube f bar s minus s square f of 0 minus s f dash 0 minus f double dash 0, so on. L of n derivatives of the given function f of t is equal to s raised to n f bar s minus s raised to n minus 1 f of 0 minus s raised to n minus 2 f dash 0 minus so on s times f n minus 2 0 minus f n minus 1 0. So many times this property is given directly 2 marks. What is the statement directly in the questions? Now I am giving the explanation with some logic. Whatever the derivative, the first term starts with the degree of that s. So the degree of s is nothing but the order of the derivative, that is in the first term only. Here second derivative s square starts with s square, third derivative s starts with s cube, nth derivative starts with s power n, and next onwards it is go on decreasing by powers of, it is go on decreasing by the powers 1, s square s, s power 0, s cube, s square s. So it starts with s power the order of the derivative and go on decreasing by 1, the powers decreasing by 1. Next each term multiplied by respectively, first with f bar s, next if any f of 0, next if any f dash 0, next if any f double dash 0, that is derivatives are increasing by 1. Okay. Just I have generalized with these three nth result. So the last term 0 derivative, first derivative, difference is 1. Second derivative, first derivative, difference is 1. Third derivative, second derivative, difference is 1. Here n derivatives, that's why I end with n minus 1 derivatives at 0. The next property is Laplace transform of integrals. Laplace transform of integrals. L of integral 0 to t f of t dt is equal to 1 over s f bar of s. Here in the previous problem, Laplace transform derivatives, that is the first term f bar s pre-multiplied by s. Here the f bar s which is dividing with s. Okay. Sorry, Here in the previous problem multiplied by s to f bar s. Now here s is dividing to the f bar s. Okay. So sometimes the inside term using definite integral properties, this can be written as f of u without changing the limits. You can change the variable also, or in some textbooks. Next, similarly 2 times with same limits, 0 to t, f of t dt is equal to 1 over s square f bar of s, etc. Just sending this L into that side, which becomes inverse property, inverse Laplace transform property. That's why I am not writing. See the example. Find L of integral 0 to t e power minus t cos t dt. So just compare the property. This is taken to be f of t. Solution. So here, before finding the Laplace of this function, we have to first take cos t and find its Laplace and then apply first shifting theorem. That means a problem containing not only one property but also more than one property. Okay. So we start with finding or taking the Laplace of cos t, since L of cos t is equal to s over s square plus 1. Don't say this is f bar s. Okay. Therefore, by first shifting theorem, L of e power minus t into cos t. Whenever e power minus at multiplying, s is replaced by s plus a divided by s plus 1 whole square plus 1, since a is equal to 1. Now this is, I have taken f of t, comparing with that problem with this first statement. So this is denoted by automatically L of f of t is f bar s. Therefore, by Laplace transform of integrals L of integral 0 to t f of t is e power minus t cos t dt is equal to 1 over s into f bar s. What is f bar s? S plus 1 divided by s plus 1 whole square plus 1. That is the answer. Next, change of scale property. L of f of at is equal to 1 over a f bar of s by a. Similarly, L of f of t by a is equal to a times f bar of as if a not equal to 0. Suppose L of some t term is given whose value is f bar s. Now in that t term, if it is replaced by 2t, 3t, the problem is given like that. Suppose L of sin t by t is given. Now the question requires L of sin 2t by 2t like that. That is, t is replaced by a into t like that, or t is replaced by t by a. In inverse, So in inverse, L inverse f bar of As is equal to 1 over A f of T by A. L inverse f bar of S over A is equal to A times f of AT. See, example, find L inverse, I am not giving any function, just 3s plus 2. Solution. L inverse f bar of 3s plus 2. First it is in the form of s plus a after taking 3 outside. That is L inverse f bar of 3 into s plus 2 by 3. So wherever it is s, it is in the form of s plus a. First of all, comparing with first shifting theorem. A is equal to 2 over 3. E power minus 2 by 3 times t L inverse f bar of, then s is replaced by s. That is, sorry, s plus a is replaced by s. Since by first shifting theorem A is equal to 2 by 3. That is the property first I applied in inverse. Now it is in the form of L inverse of f bar of As, where A is equal to here 3. And here I am writing is equal to e power minus 2t by 3 into L inverse of f bar of As 1 over 3 into f of t by 3. Since A is equal to 3 by scale property. That is the reason. So in this problem, first I have applied first shifting theorem inverse and then change of scale property. We don't know that function of s. That's why we don't know this value f of t by 3. Next, evaluate 0 to infinity e power minus t sin t by t dt. So 0 to infinity means that is Laplace transform definition, 0 to infinity. And then next term see e power minus st, comparing with that. So this term is taken to be f of t. Here I am not asking the Laplace of this function. I am evaluating this integration value. This problem cannot be done using your normal standard methods which we have studied in 11th 12th standard. Integration method is not applicable here. It is difficult. It is sometimes the value is not that means the integration, it is not evaluated by your original methods what we have done in 11th 12th standard. So this type of problems purely by getting whose answers getting by Laplace transform only. So this is I am taking what I highlight the term that is going to take function t, f of t. Since in that basic term is sin t, because we cannot find directly sin t by t, or one problem I have done using division with t, L of sin a t by t. If you remember that problem, the last step as a formula, then substitute a is equal to 1. Okay, just it's saving the time only. Anyhow I am doing L of sin t is 1 over s square plus 1. Therefore L of sin t by t, that means which property I am going to apply now? Division by t. S to infinity f bar is 1 over s square plus 1 ds. This problem I have done same. I have done already this problem sin a t by a by division with t. Okay. Now this is tan inverse s, limits s to infinity, and simplifies to cot inverse s. Just refer the previous problem. Okay. So now I am comparing this inside term as f of t. So L of f of t denoted by f of s. Therefore by definition of Laplace, by definition of Laplace, what is that? 0 to infinity e power minus st into sin t by t dt is equal to cot inverse s. So this term we already calculated Laplace. This is denoted by f of t, L of f of t, 0 to infinity e power minus st by definition. Now comparing the given integral with this step, we have to take properly a value to it. We have to give a value to s. That means this tells that this is a definite integral value. So far we have the problems, the Laplace problems which is in terms of s only directly. Now this is not a Laplace problem. We are going to evaluate this integration using Laplace transform, and this is a definite integral. So finally we will be getting a number only, not s. So what we have to choose the number or value to s, comparing with putting s is equal to 1. Put s is equal to 1, we get 0 to infinity e power minus t sin t by t dt is equal to both sides cot inverse 1, tan 45 cot 45 1. So this simplifies to pi by 4. But it is difficult to integrate by the normal methods, standard methods or integrations methods, okay, which you have studied in 11th 12th standard. Okay. And just make a note point using this problem. Okay, 0 to infinity sin mt by t dt is equal to two answers. Pi by 2, very very important, better to remember as a formula, minus pi by 2 if m less than 0. Just this is obtained by the above procedure by taking last step s is equal to 0. M means maybe positive or negative, greater than 0, less than 0. So better to remember as a formula. Okay, depending on m values you write pi by 2 minus pi by 2. This procedure, this answer is obtained by using above problem procedure, after that is in the last step taking s is equal to 0. So the last property here, Laplace transform of periodic function. So have you all remembered that periodic function definition? F of x plus p is equal to f of x for all values of x. That p is called period. The least of all the periods is called standard period or fundamental period. Okay. If f of t is a periodic function with period say or denoted by capital T, that is f of t plus capital T is equal to f of t for all small t, then such function Laplaces L of f of t is equal to 1 over 1 minus e power minus s capital T integral 0 to capital T e power minus s small t into f of t dt. Just it looks like the procedure of Laplace of function. Instead of infinity it is capital T, the pre-multiplication extra term only. So this example, so that means the periodic function geometrically is the graph of f of t gets repeated after every interval of length capital T, where T is the period. Suppose sin x graph we know 0 to 2 pi, how to draw and how to plot that points x values, y values, and then joining the points by a smooth curve. After getting the curve sin x graph between 0 to 2 pi, whenever you want 2 pi to 4 pi, not required to find again x values, y values, plotting all these points, joining these points, just it is whatever the 0 to 2 pi the graph is there, it gets repeated 2 pi to 4 pi, 4 pi to 6 pi. Okay. So example which is given 2003. The Laplace transform of the function zero, this number 1, this number minus 1, 1, 2, 3, 4, 5, and the graph is so this is a rectangular wave function whose length is 1, height is or breadth, like this. So if you consider that this is 1, 0 to 2, the graph, this shape, the same shape repeated 2 to 4 and 5 to 6. So which is a periodic function graph, where taking the horizontal axis t and the vertical axis is f of t. Okay. Solution. Clearly f of t is a periodic function with period capital T is equal to 2, 0 to 2, 2 to 4 it is repeated. Therefore, L of f of t is equal to 1 over 1 minus e power minus s into the period is 2, integral 0 to 2, just in the above formula put capital T is equal to 2, e power minus s small t into f of t into dt. Now we have to find the f of t values. Here we don't have directly 0 to 2 the graph, 0 to 1 one shape, 1 to 2 other shape. So we have f of t is equal to the first one, 0 to 1, what is that? It is a horizontal line through 1, that is 1 if 0 less than t less than 1. In the other case, your f of 2, 1 to 2, it is below horizontal axis, which is parallel to minus 1, which is passing through minus 1, that is minus 1 if 1 less than t less than 2. So that is the function value. So this is simplified to 1 over 1 minus e power minus 2 using properties of integrations 0 to 1. First function value is 1 plus 1 to 2. The second function value is minus 1 dt, and you know how to evaluate. That is simple integration, not required by parts or any other method. So this is simplifies to 1 over 1 minus e power minus 2s times e power minus st by minus s. E power ax integration is e power ax by a. And this is minus, keeping minus outside, e power minus st by minus s, whose limits 1 to 2, this is. And I am simplifying here. 1 over 1 minus e power minus 2s, s is also getting common. The inside terms, after simplifying, after substituting the limits, it is going to become 1 minus 2 e power minus s plus e power minus 2s, e power 0 1, like that. So the numerator can be written as 1 minus e power minus s whole square, a square, that is 1 square. If you write 1 is equal to 1 square and 2 into 1 into, like that. E power minus 2s is e power minus s whole square. So that the numerator is a minus b whole square. Now the denominator, if this 1 is equal to 1 square, it is in the form of a square minus b square. So 1 minus e power minus s, 1 plus e power minus s into s. Because this answer is not matched in the options, then you simplify further. So this is simplifies to 1 minus s times 1 plus e power. This is the answer. If your answer is not matching with the options, then only you simplify further.